Good morning, folks, and good news. As you can see here, there was a full recovery of the SDO satellite, and it turns out it was just a slew to capture the middle corona and conduct some secondary operations for the Parker probe. You can read about it at their website. Meanwhile, we're staring down a massive coronal hole. We've got some key updates today, but we're starting here because although space weather appears quiet, it will not be that way at Earth for long. Overnight in the solar wind, we took the flip, the phi angle, in blue, and it is causing a slight excitement to the field, and when the coronal hole stream solar wind impacts in the next day or two, we should expect minor geomagnetic storms. Let's get our eye candy out of the way here from Hubble. Scientists' impression of the dynamics around a young planet that is just about done forming. Interesting to see the polar cusp interactions leading into the auroras, like they took a page right out of plasma cosmology or the electric universe. And keeping that interaction in mind, let's go to the same form of interaction between a planet and its star. Through those same connections at the polar cusps, which integrate with the star's magnetic field, the planet is inducing eruptions and transient brightenings from the star. We have an entire playlist about those planet-star interactions, which can be found by clicking our name and looking for the playlist called The Planets and the Sun. Up next is a critical one that leads us into our ending lesson for the day. Mammalian brain size and apparent intelligence not only does not follow body size, but it comes in jumps, right after catastrophes. This makes sense when you realize that the biggest animals are in the most trouble in the disaster, and it probably takes a good bit of intelligence to survive. Speaking of surviving the disaster, the next one is on its way, and that's why I didn't share these two magnetic excursion papers from the EGU meeting. But here at the last day of that meeting, let me explain a bit more. Both of these works are describing important items related to magnetic events on Earth, but both incorrectly say the last two excursions on Earth were LeChamp and Mono Lake in the 40,000 and 30,000 years ago range. Problem is, those were not the two last excursions. In the Field Setting Literature Review of 2019, they highlighted the horrible effects of the actual last one, Gothenburg, about 12 or 13,000 years ago. In their tracking of biosphere die-offs, they find peaks at the 12,000-year cycle, and even when the official next to last, Lake Mungo 24,000 years ago, is left off the list, you can see there should be something else in the middle. The problem is that these are hard to see in some parts of the world. Pick your spot and you might see LeChamp and the 18,000 years ago half-cycle event, Helena Pali, while Mono Lake seems to be less apparent. Lake Mungo is not only a solid event, but with its matching the last glacial maximum, it hits the cold trigger more than any other excursion. Sometimes the data is so difficult that Mono Lake and Lake Mungo actually get confused or combined into one event. Regardless, I've merely shown a handful of the literally hundreds of papers on Gothenburg and Lake Mungo, and those were the last two cycle events. Here is a look at both the 12,000-year cycle and the 6,000-year half-cycle events. The half-cycles oscillate between magnetic minima and maxima, unlike the 12,000-year cycle, which are all minima excursions. All of them bring cold events, all bring biosphere stress, volcanoes, and the next age of Earth.